In this lesson, we're going to start using the sine and cosine ratios for other triangles. They actually work for any right triangle. They do not have to be 30, 60, 90, or 45, 45, 90. We can have any angles, even angles with decimal values. So you can use the sine and cosine ratios to find an unknown side if you know the angle and the other side in that ratio. So could it be a leg or it could be the hypotenuse? So, first of all, when you're doing these problems, you will be using calculators primarily. You need to make sure your calculator is in degrees, not radians mode. So you find that by hitting the mode button. Highlight the known angle, find its opposite and its adjacent sides. Highlight the known sides. Is it opposite, adjacent, or hypotenuse? Highlight the unknown side in a different color. I like to make my opposite angles match color with my opposite sides. That way it's easy to pick out if it's opposite. Set up an equation where one side is the sine or cosine of the angle, depends which problem you're doing, if you're working with the opposite leg or the adjacent leg, or if that's what you're looking for. And the other is going to be the ratio of the appropriate leg over the hypotenuse. Solve for the unknown. One big thing, once you set up sine of blank equals blank over blank, one of the easiest things you can do is you can put a 1 under that trig function, and that way you can make it easier to cross multiply. And use the calculator to find your approximate answer if necessary. There will be times I'll just ask you, what is the ratio? And you're going to solve for your unknown, and your answer might have sine or cosine in it, and that's fine. So to use sine, you must know 2 of the 3 following values. You need to know angle, opposite leg, and or hypotenuse. So in this example, we have a triangle, 64 degrees, so it's close to 30, 60, 90, but it's not. And the hypotenuse is 12 feet. So I'm going to go ahead and highlight my angle on the opposite side. And I'm pretty sure I'm going to use that 64 degrees. We almost never use a 90-degree angle. I'm going to highlight the hypotenuse, and I don't think I'm going to need the adjacent. I'm not looking for it, and I don't know the value. So I'm going to use that sine is opposite, in this case, the yellow side over the green side. So it's opposite over the hypotenuse. Substituting in, I'm just going to put an x for my unknown side here. So sine of 64 is x over 12. Put 1 under this side to make it easier to cross multiply. And I get 12 times sine of 64 is x. Well, I'll just substitute. Since you may not have a calculator, I put this number up here for you. And you can go 12 times 9/10, and you get 10 8/10 of a foot, 10.8 feet. In this problem, we actually know the opposite angle, and we're trying to find the hypotenuse. So there's the hypotenuse that we're looking for. There's our angle, and there's the opposite side. So I set up my ratio like before. Sine of the angle is opposite over hypotenuse. So sine of 49 is 14.5 over x. Put a 1 underneath to make it easier to cross multiply. And I'm going to get x times sine of, and that should be 49. Let me fix that there. That should be a 49. Probably that 14.5 threw me off. And equals 14.5. Now, here I'm trying to solve for x, and that means that I want to divide by both sides by whatever's multiplying the x, and it's a trig function. So I'm going to divide both sides by sine of 49. Pretend that's a 9. Okay, so dividing both sides by sine of 49, I basically get x is 14.5 over sine of 49, and we know that sine of 49 is 0.755. I can now put this in my calculator, and I get about 19.2 inches. To use cosine, it's very similar, but I don't need the opposite leg. I just need either the adjacent leg or the hypotenuse and an angle. In this problem, it's the same as before. I'm going to do 12 feet, but this time I'm going to find the adjacent leg. So let this one right here, and there's the opposite to the angle, and here is the hypotenuse on bottom. So I'm going to say cosine of angle A is AC, the adjacent side, over the hypotenuse, and substitute in values. So cosine of 64 is AC over 12. Go ahead and put a 1 under the cosine to make it easier to cross multiply. and you get 12 times cosine of 64 equals AC. And notice I'm using the segment name instead of a variable. That's fine as well. It doesn't matter. I could have used X. Now I'm going to substitute in the 438 thousandths, 0.438. And that is in case I gave you that up here in case you didn't have a calculator. And I get 5.256 feet, or 5 and 256 thousandths. In this example, I'm going to find AB, which is the hypotenuse. And I know the side that's 9 inches here. And so since I know the angle here and I know the adjacent side, I'm looking for the hypotenuse. The trig ratio that uses adjacent and hypotenuse is cosine. That's why I gave you cosine of 35 degrees here. So I'm going to go ahead and mark that. I will not be using the opposite side there, the BC. So cosine of angle A is AC over AB. Substituting, I'm going to put in 9 over AB. Put the 1 underneath so that I can cross multiply. AB times cosine of 35 is 9. I can divide both sides by cosine of 35. And here I'll use 0.82 as that value. So I get 10.98 inches, or 10 and 98 hundredths. So just to recap, you're going to have to be able to tell when to use sine and when to use cosine, and when to use tangent. So if you know an opposite leg, then you're probably going to use either sine or tangent, depending if you're looking for hypotenuse or adjacent. If you're looking for hypotenuse, it's sine. If you're looking for adjacent, it's tangent. If you know cosine, if you know an adjacent side, then it's either tangent or cosine. So if you're looking for hypotenuse, it's cosine because they're adjacent in the hypotenuse. If you're looking for opposite, again, it would be tangent.